Welcome to the DIY Honda Garage channel. Welcome to this troubleshooting guide focused on DTC P0A94, which indicates a performance problem with the DC-DC converter in the 2023 Honda CR-V. This error occurs when the powertrain control module, or PCM, detects a failure in the DC-DC converter's operation. The DC-DC converter plays a critical role in providing a stable DC voltage for the vehicle's electrical systems by converting high voltage DC to lower voltage DC as needed. It is typically located under the hood, near the vehicle's battery and inverter systems. The PCM closely monitors the performance of the DC-DC converter and generates this diagnostic trouble code when an irregularity is detected, prompting further inspection of the converter and its associated circuits. The DTC P0A94 indicates a detected failure in the DC-DC converter, which is essential for managing power in the vehicle's hybrid system. The PCM, or Powertrain Control Module, serves as the brain of the vehicle's operations, monitoring various components, including the DC-DC converter. When an abnormality is recognized, the PCM logs this performance issue and stores the DTC for diagnostic purposes. The DC-DC converter primarily manages the voltage levels necessary for the vehicle's electrical and hybrid systems. It is usually found in the engine compartment, close to the vehicle's battery and associated electrical components, where it can effectively supply the required power for various systems. Several potential causes could lead to the DTC P0A94 being triggered. One significant factor could be shorted wiring in the circuit leading to the DC-DC converter. This can disrupt the electrical flow, causing the converter to operate incorrectly. Additionally, a faulty DC-DC converter itself may lead to performance issues, and failing internal components within the converter can manifest this error. Another possibility is damaged or malfunctioning power circuits associated with the converter, which can lead to inadequate voltage being supplied. Finally, if these components check out normally, it may indicate a problem with the PCM, which could be misinterpreting the data and generating an erroneous DTC. When DTC P0A94 is present, several symptoms may arise indicating a malfunction. One common sign is the activation of warning lights on the dashboard, alerting the driver to potential issues. You might also notice a reduction in electrical performance, such as dimmer lights or sluggish operation of electrical components. In severe cases, the vehicle may fail to start altogether due to insufficient power being supplied to crucial starting systems. Additionally, drivers may experience erratic power supply to certain components, leading to unpredictable vehicle behavior. Awareness of these symptoms can assist in early identification, prompting timely diagnostic checks. The first step in troubleshooting DTC P0A94 involves performing a test drive of the vehicle. This is crucial, as it helps replicate the conditions under which the error code was generated. Engage the Auto Idle Stop feature to engage automatic engine shutdown during stops, allowing for observation of how the vehicle behaves when idling. This initial test can help identify any immediate symptoms or behaviors related to the DC-DC converter issue. Pay attention to any warning lights that activate during this test, as they may provide further insight into the operational status of the vehicle's systems. In the second troubleshooting step, a thorough inspection of the DC-DC converter circuit is necessary. This involves checking for any short circuits within the wiring that connects to the DC-DC converter. A shorted wire can significantly impact the converter's ability to function properly and generate the necessary voltages. It is important to visually inspect the connectors and wiring insulation for any signs of wear, fraying, or damage that could lead to an electrical short. Additionally, Using diagnostic tools to check resistance and continuity in the wiring can help pinpoint the location of any faults. Next, it is essential to review the power supply inputs to the DC-DC converter. This involves checking the plus BIS and GND circuits to ensure they are providing adequate voltage for proper operation. Using a multimeter, measure the voltage levels at the designated points while the vehicle is in IG mode. Proper voltage readings should reflect expected values, indicating a functioning power supply circuit. Furthermore, checking ground connections for continuity and low resistance is vital, as improper grounding can lead to performance failures in the DC-DC converter. If inconsistencies are noted in these supplies, further analysis will be warranted. In this step, it's crucial to inspect the output circuits of the DC-DC converter, specifically the DC-DC out 1 and DC-DC out 2 circuits. These outputs are responsible for providing power to various components within the vehicle. During this inspection, confirm that there are no aftermarket parts connected to these circuits that may cause unexpected behavior. After confirming the circuit is clear, utilize the Honda Diagnostic System, or HDS, to check for any output errors reported by the converter. If the HDS indicates abnormalities in the output readings, it reveals an issue with the DC-DC converter's performance, prompting the consideration of replacement if needed. The following step involves conducting an internal circuit inspection of the DC-DC converter components. While direct testing of the internal circuits is challenging, the procedure assesses related components using the HDS to check for any input or output errors. Key parameters, such as the DC-DC converter CST error and input-output readings, must be examined. It's essential that the values returned from the HDS fall within normal parameters to verify that the internal components are functioning correctly. If any parameters are reported as abnormal, further inspection of those specific components is warranted to ensure overall functionality. If previous inspections indicate the internal circuits are functioning correctly and the error persists, a logical step is to replace the DC-DC converter itself. Installing a known good DC-DC converter allows technicians to isolate whether the issue resides with the component or elsewhere in the system. After installation, it is crucial to recheck the vehicle using the Honda Diagnostic System to determine if the error code has cleared. If the new converter resolves the issues, it indicates that the original component was indeed faulty and needed replacing. The final troubleshooting step involves conducting a detailed inspection of the Powertrain Control Module, PCM, if all previous checks have revealed normal operations. The PCM is critical as it manages numerous vehicle functions, including power management through the DC-DC converter. To ensure it isn't the root cause of the problem, confirm that no additional error codes are present that might indicate PCM malfunction. If all systems appear to be functioning and the PCM still raises a concern, it may warrant further diagnostic analysis or replacement, confirming that it is operating within manufacturer specifications. Once all necessary repairs or component replacements have been conducted, it is critical to perform a final repair verification to confirm that the issue associated with DTC P0A94 has been resolved. This involves using the Honda Diagnostic System to check that all fault codes have been cleared from the PCM. Following the code clearance, a test drive of the vehicle is mandatory to ensure that it operates as intended and that no warning lights are activated. Monitoring the vehicle's performance during this drive will help confirm the success of the repair and ensure that proper power is being managed throughout the vehicle's systems. Preventive maintenance is crucial to mitigating future occurrences of DTC P0A94. Regular inspection of the DC-DC converter and its associated wiring circuits can help identify wear or damage before it becomes a significant issue. Maintaining an eye on the vehicle's electrical performance can also aid in detecting any inefficiencies early. If any signs of fault are observed, such as erratic power or warning lights, addressing them promptly can prevent further complications. Establishing a routine check of electrical systems within the hybrid vehicle ensures long-term performance and reliability. In conclusion, DTC P0A94 serves as an important diagnostic indication of the DC-DC converter's performance issues in the Honda CR-V 2023 Plus. A detailed inspection procedure must be adhered to in order to diagnose the root cause accurately. Component replacements, such as the DC-DC converter or PCM, should only be conducted after thorough testing implies these are faulty. Following successful repairs, a final verification is essential to ensure the error code has been addressed completely. Regular maintenance practices will help avoid recurrence of these issues, promoting the longevity and reliability of the vehicle's performance. Please like and subscribe to the channel. See you next time.